Hello everyone, how are you? So I hope your examination, which is of chemistry, went really well today. I have seen that the chemistry paper, it's so easy. Means like everything was done in the session, every single thing. And in the last session, when we were having a small doubt sessions there, so in that case, whatever the doubts which we have taken, all those doubts and everything has been cleared, right? So everything was done very clearly. Yes or no? Okay, so in that case, today we are going to start. Today we are going to see basic about it, and we are going to review the paper today. And yeah. So let's see here that how was the paper and how we can actually do this paper. So one by one, we are going to see with the answers, all the questions and everything. And let's see that how the paper went. So I believe that the paper went was really easy for everyone. If it is not easy, if you are finding it was a difficult, there's no issue. It's okay. Yeah, I can see that in the link. Yeah. So we can see in the link what has happened. That in the link you can see that they have provided you with the sections. There are actually a little difficult. Otherwise, every set was really normal and a good one. Yes. I can see that few students have joined here as well with me. So I hope you guys have done the good paper. Well, you can speak up. You have one doubt. What is that doubt? Meanwhile, I'll share the paper with everyone. This is I opened the set A paper. This is the set one. I didn't got your doubt. I will send it there. Okay, you are sending me doubt. You can send me anywhere, wherever you want to send your doubt. I hope you can tell me in the comment section that how was your paper, how it went, everyone. I believe that this is the most easiest paper you can do. You can send me here also. You can let me know which question number it is. It was good. It was really good. It was very easy paper. Only section C, I can say it was slightly difficult. Otherwise, it was very good paper. You had set two. Set two is also very easy. The set one and set two has almost same question. And which series paper it is? Okay, I have to check which series paper it is. Let me just check. Just give me a second. Mm-hmm. It is your. Sorry, I don't have a series right now written with me. So just a question I have with me. They didn't share the series with me. But you can give me the question. There is no issue. I can go to the section C directly. Section C. Can you? Okay, let me just don't see. Yeah, you can have it. Just a second. In the section two, we have C. Let's see one for the first question, and then I can give you all answers one by one, and we'll discuss all the paper here. Yes. So here it's section C. Yeah. Question number 24. That was the most easiest question. I did it in one method. No, ma'am, listen. What do you want me to listen? Okay. Okay, I'll give all the answers one by one. Just don't put your questions here, so it will become very difficult for me. Okay, this question was there in set A, B, C, and D. So let me explain this question, they have given you P naught value 1 mole, and they have given you N1, that is 50 moles. And the second thing they have given you that A, B is an electrolyte and will dissociate completely, giving you A plus B minus. So I factor is 2 here, right? Good. So in this question, what will happen? Most of the students have done this question. I don't know how, but in the class, in the last session also, I've told you whenever you get a relative lowering of vapor pressure type of a question, in that case, you always have to use this formula, that is P naught minus PS by PS is equals to N2 upon N1 into I here. This is the formula which we use for the calculation. This is not relative lowering of vapor pressure, but you have to use this formula. Is that clear? Those who haven't used this formula, I don't know what you have done in the paper. So in this case, the P naught is 100 minus PS. We need to calculate PS. We don't know. N2 they have given you 1. N1 they have given you 50. And they have said that it is 2 here. This was the question. You have to use it. It's okay. There's no issue with that, because now most of the time students actually make a blunder in this one, as they were taking a mole fraction. But whenever you learn the relative lowering of vapor pressure, I have a different formula and concentrated and the dilute portion. So what happens whenever we solve it using this formula. Okay, you have done with the Raoult's law. No issues. Okay, let's come back here. Let me give you one by one. Then I'll take all your doubts. Everyone will get your clear answers here. Okay, the first question. In the last session also, I have told you that the reaction or the preparation of KMnO4 or K2Cr27 will be asked. KMnO4 preparation. First step, it will give you K2MnO4. Good. ADTA, polydentate ligand. If anyone has done this question wrong now, I don't know what you're going to do afterwards. Then chelating ligand. So nothing is chelation, only the first one, that is your oxalate ion, is a chelating agent. sp2 hybridized carbon. So technically they were asking you vinylic carbon here or vinylic position. So who is vinylic? The C option. Then we have most acidic. Now see, most of the students have done the D option. That is wrong. Chlorine shows plus M effect. And this was the next question which they have asked you. I told you in the last time, if you don't know the answer, always read the paper. In the next questions, they sometimes give you the answer. And you will see in the question, they have given you one question that chlorine being negative or the electron withdrawing group, still it is orthoparadirecting. Why? So it was orthoparadirecting means it is a plus M group. So the correct answer is B option. Because the phenoxide ion is much more stable because of resonance. Anisole, this was the best reaction. Every time whenever we learn this reaction, we have done this portion, that whenever you have an anisole, means pH is attached with OCH3 and you are adding HI. In this case, phenoxide ion is the most stable ion, so it will give you phenol along with the preparation of CH3I here. So the answer will be A option. Is this part clear? Do give me if you have this set. I hope you have understand this portion. This was 56/2 series. Next, what do we have is H2SO4 at 413 Kelvin. I told you at 433 or above Kelvin, in that case, it will go with a reduction. At 413, it is just where you will get the ethanol, alcohol, oh sorry, ether preparation. Absolutely correct. So the correct answer is ether preparation. 413. This will formed at 433 Kelvin or so on. Specifically written in NCERT book. Means that this time everything they have given exactly at the NCERT. Now above 433, 443 you can take. In the NCERT, if you read, it was written above 433. I am giving you the answer for the assertion and reasoning also. Just wait. Okay, so when we talk about the assertion and reasoning question here, Okay, sorry. The question number eight. Azeotropic solution for the two liquids have a boiling point lower. Lowering of vapor point means minimum boiling point. I told everyone minimum means opposite, that will be positive. Maximum boiling point means negative deviation. So it will show positive deviation. Clear? And ninth question, I don't understand. It's the simplest question they have given just in a language way. That is a relative lowering of vapor pressure of an aqueous solution. So they have given you P naught minus PS upon PS here, which is mole fraction of 2. And this is values given 0.0225. The mole fraction of non-volatile solute. Direct answer. Then NaCl, this is the favorite question we have learned in the sessions as well. So NaCl, when in the presence of water, aqueous solution is given. When you electrolyze, you will be getting NaOH in the aqueous form, plus chlorine gas, plus and hydrogen will be at cathode. Reduction is occurring. So the A is the answer. Rest all are incorrect. This question, the catalyst, activation catalyst, we have learned in the 11th grade also, here also, it affect activation energy. Always learn with a graph that this is your R, this is your pre, this is normal reaction. With the enthalpy, you will change this one. Changes the activation energy. Question number 12. Let's see. P is giving you this with the factor of R. So R1 is what it is given to you is Kp raised to the power x, and R2 is given to you 8 times of R1, which is equals to double the concentration 2 pi x. So divide this equation. So 8 by 1 is equals to 2x px by px, here cancel. So x is equals to 3 here. So answer is third order. Now assertion reasoning, what the questions the students are waiting so eagerly. Let's see. Okay. The aliphatic primary amine can be prepared by Gabriel thalamide. Yes, in the doubt session, I told you in the Gabriel thalamide, we have only able to prepare aliphatic primary amine. Aromatic primary amine doesn't show nucleophilic substitution reaction. So this is true. Alkyl halide undergo nucleophilic substitution reaction. This is also true and correct explanation also. In the last session, in the every class, whenever we having the doubts for the normal your boards in the assertion reasoning for your IIT also, I'm telling you, whenever assertion reasoning you have to solve, read the first statement, write because alkyl halide undergo nucleophilic substitution reaction with anion. True. Okay. Uracil is a base present in the DNA. No, it is a thiamine. Then next we have is DNA undergoes self-replication. That is true. So B option is correct. Here A option is correct. And diazonium salt of aromatic amine are more stable than aliphatic amine. True. Next, diazonium salt of aliphatic amine shows resonance. And that is false. Next, para-nitroaniline is a weak base, then para-toluidine. Correct, true. And the electron withdrawing group of NO2 group in the para position make it as a weak base. That is also true. Let's go with the next one. Oh, next one is very easy. I hope your assertion reasoning is clear till here. Okay, I got one question. I don't know from which set it is, and it is aniline is less basic than cyclohexylamine. That is true. Aniline is PHNH2 is less basic than when it was cyclohexamyl. The reason is aniline is resonance stabilized. It's A. The electrons are going towards the benzene. Is it clear? No, this is not B because A is false here, so I don't. Option D is correct. And B is false. When R is false, option C is correct here. Let's go with the next one. So we have 6%. I told you in the class, whenever they were giving you percentage, so it is percentage mass by mass. So it is 6 grams glucose is equals to 2.5 gram of organic unknown compound. We need to find the solution and they are isotonic. Isotonic means pi 1 is equals to pi 2. As nothing is given, so we are considering R, T and volume all are same. So that means C1 is equals to C2. That means N1 is equals to N2. So 6 divided by 180 is equals to 2.5 divided by unknown. So I'm taking M. M is equals to 2.5 into 180 divided by 6, 30, 75 grams per mole. That is the correct answer. I told you A is the correct answer here. Let's go with the next one. Okay, next one. Most of the students have done with a very long method. If you see it very correctly, what they have given you from 5 to you are reducing to 2.5, half reaction, direct formula. So how long will it take? So T half is equals to how much? 0.693 divided by K. Simple. You don't even need log. Is that clear? Okay, while what is lanthanide contraction? Due to poor shielding effect of 4f electrons, the size of the atom doesn't decreases and the outermost electrons are closer towards the nucleus. Actinoid contraction is greater for elements to element than lanthanide contraction. 5f has even poor shielding effect than 4f, due to which the energy gap between the 5f, 6d and 7s is very low and they are very close to each other. And that is also a reason why actinoid able to show the maximum oxidation state. In lanthanoid, they only show +2, +3 or +4. In actinoid, you can get +7 also. Okay, or question, why do transition metal have high enthalpy of atomization? Because of metal bonding or metallic bonding. So metal-metal interaction is very high, due to which to separate them and get a single atom out of it, it's required a very high amount of energy. Which metal of D series has the lowest value? This you learn from the 7th grade that zinc is brittle in nature. You can break down. So atomization energy of zinc is very low. Good. Next, this is the SN2 mechanism. See, SN2 question was asked in the every form in the different ways. So SN2 is favored by 1 degree, 2 degree, 3 degree, like that. And in the case of the halides, so iodine, then you have bromine, then you have chlorine. Fluorine doesn't show with SN2. Fluorine also shows, but very rarely. So this is the actual order. So in this case, what will happen? It will give you I minus, because I minus is a better leaving. Simple answer. Who? UV radiations. So where will you get a UV radiations in this case? So in the case of benzene, you will be getting CHCl, CH3. No other way. Best because the free radical which is generated here is most stable. Denaturation of protein because of higher temperature, when protein loses their behavior and from quaternary structure they reduces to primary structure. Told you every time the denaturation of protein will be there. Invert sugars, especially sucrose, property of sucrose. So when you hydrolyze sucrose from dextrorotatory, it becomes levorotatory. See, in this case, now, if students have written sucrose also, or invert sugar is like converting their optical isomerism, you will get half of mark. Okay. Now the reaction. See, I told you, you have to see the name reactions first in any format. So whenever you are doing any question, always see the name reaction. Like by default, whenever seeing this question, I don't have to see anywhere. I can see that this is by default a disonium salt reaction. So wherever it is, diazonium salt has to be formed. And if I have NaOH plus Br2, either I have Hoffman bromamide or I can have the halo form test. There is no other form. So let's see for the A1. So what I am getting in the first step, so I'll get CH3, CH2, and then there will be CN here. They have written partially hydrolysis. This was the question we have done in the DRS also. They have to specify for the partial hydrolysis. So in the case of partial hydrolysis, I'll be getting C double bond O NH2 here. So it is a Hoffman bromamide name reaction. So what is the product here? So product is you will be getting CH3, CH2, NH2. One carbon is lost in the form of Na2CO3 plus NaBr plus water is formed. You can balance the equation. Is that clear? Good. Now the diazonium salt, because it is a diazonium salt reaction, so before that I have to have an aniline. So if you don't remember what will happen with the iron, you will get A as aniline. Because next step I'm getting diazonium salt. Now this is the property of a diazonium salt. If you add ethanol or if you are adding a phosphorus oxide, so in that case you are getting benzene ring here along with the formation of N2 and the aldehyde here. Again, I told you that whether you are going to get a Clemmensen reduction or a Wolff reaction, out of two, you will get one. So Wolff-Kirchner, whenever you are taking any aldehyde or a ketone and adding NH2, that is hydrazine, in presence of a glycol, proceed with the KOH. So you are getting alkane here, along with the formation of the other groups. Decarboxylation, simple, you have to take any acid from the 11th grade you are learning, add NaOH in presence of calcium oxide. So you'll be getting RH along with the formation of Na2CO3. Canizaro, I told you that either they're going to ask you aldol or either they're going to ask you Canizaro. In the paper, they have asked you both the reactions. Canizaro in the form of this one and aldol in the form of a reaction afterwards. So when you see this Canizaro reaction, so Canizaro, I can go with the simple, I can take benzaldehyde. And in that case, I can add NaOH along with small heating and I can take conch here. So what I'm getting as a product, I'll get PHCOO minus acid, benzoic acid salt, sodium benzoate along with the formation of benzyl alcohol. Simple, straightforward questions. Okay, and now phenol from chlorobenzene. Okay, so if I have chlorobenzene, in the last class also I told you that there are two reactions by which the benzene shows the nucleophilic substitution reaction. One is Dow process and another was your cumene, phenol preparation. So both are phenol preparation. So here you have to take NaOH and heat it. You will be getting phenol here. Salicyl aldehyde from phenol, Riemann-Tiemann reaction, discussed in the last session. OH add a CHCl3 in the presence of KOH. You are getting OH here and CHO here, salicyl aldehyde. Any sol to, okay. Now this is a little confusing question because if you don't know the structure now, then you get confused. So any sol is this one, OCH3. What is the second structure? 2-methoxy. So at second position, I have methoxy. And at first position, I have acetophenone. So this is Friedel-Crafts reaction. I just have to add PHC double bond OCl in the presence of anhydrous ClCl3. Simple, straightforward reaction. Then picric acid from phenol, add conch HNO3, picric acid will be there. On the all three positions, you will be getting HNO2. So this is your picric acid. NO2, NO2, NO2. Done? See, it didn't even take me half an hour and we have done half of the paper, not half, more than that. So while you were reading the paper, I believe that everybody was like, oh, I'm scoring 100 out of 100. And this time I'm at least waiting that at least 3-4 students will come and say that we scored 100 out of 100 in chemistry. We should compete with the maths people. Always in the maths, there are like 10, 15 students who are scoring 100 out of 100. In chemistry, there is only one or two. This time, score 100. And for the students, if your paper doesn't go well, there's no issue. Focus on the next paper. Understand what the errors you have done here, don't do in the physics one. Study, do the NCRT portion very clearly. They are making only question paper from the NCRT, not from anywhere else. And see, this is the question which I was talking about. Chlorine is orthopara directing. So when you were doing with the above question, you can check it again. That is how you actually check. So chlorine is orthopara directing group, and though chlorine is an electron withdrawing group because of resonance. So it's a 1 mark question. Try to show its resonance also. Those who have shown the resonance, it is very good. Those who have not, okay, you have written for the 1 mark. Racemic mixture is optically inactive, true, because 50% is dextrorotatory and next 50% is levorotatory, so they're cancelling out each other's effect. Allylic chloride is hydrolyzed more readily than N-propyl chloride. First, allylic chloride, so this is your allylic chloride. And from the N-propyl chloride, because here positive charge will be more stable, resonance stabilized. And there only hyperconjugation will work. That is the major reason. Thank you, those who are giving me stars. Okay, I got one more question. Question number 20. Sorry, I didn't see it. So question number 20, they were giving what if we have a cyclohexene? In which one? Where you are comparing? Question number 26, you are comparing. Yeah, that is an NCRT question. I told you there is not even a single question they have given you from even exemplar. All the questions are directly from NCRT. Directly. Okay, you were asking what if they have given you cyclohexene here instead of this one. This you are asking? So at one or here, you can add anywhere. That will be your major product. Because the free radical at the allylic position is much more stable in comparison to any other one. Any other query? No? Good. Take a, they will cut all 3 marks. No, they will not cut all 3 marks. First, you need to understand, as you have written the formula correctly, we do get the step marking. So as you have written the formula correctly, they will give you the marks. And we have discussed this question already. I have told you, whenever there is a relative lowering of vapor lamination also, you will get this formula. PS upon PS is equals to N2 upon N1 here into I. So approximately, yes, approximately you are getting almost same answer. There is no issue with that. But the formula should be there. Yeah, they can cut half mark or they can actually give you full also. That depends upon their checking marking scheme. Yes, you put the Rolls law, so you will be getting 1 mark. Those who have written the formula here correctly, you will get half mark for the formula. Those who have applied that formula correctly, you will get 1 mark for that. Half mark is for the answer portion. If your answer is incorrect, you will get 0 there. Is that clear? Oh, good to go. Yeah, you can expect 2 marks there. So just 1/2 mark will be deducted. Here, I told you that this Nernst equation, one question will be there. So let's see what is the Nernst equation. So Nernst equation they have given you is zinc plus Sn plus 2 from 0.001. So I'm writing 10 raised to the power minus 3. It's converting to zinc plus 2, which is 10 raised to the power minus 1 to 0. So we have to see the oxidation and reduction and calculate the value here. So let's see. What is E naught cell reduction? They both have given reduction potential, so I don't have to worry. So cathode minus anode. This is your cathode reduction and this is your anode oxidation. So it will be minus 0.14 minus 0.76. You can calculate the value, and then E cell is equals to E naught cell minus 0.0591 upon 2 electron change log of concentration of zinc 10 raised to the power minus 1 minus 2 minus 3, sorry. So my 2 will come up here, 2 will go out, minus 0.0591. This is the direct answer. 2 and 2 will cancel. See, they have given so much easy calculation also. I was expecting that they will be giving you a difficult portion. Oh, the triple the temperature. So they have given you on the Arrhenius equation. So what is the Arrhenius equation? Directly I can write log K2 by K1 is equals to activation energy upon 2.303 R 1 upon T1 minus 1 upon T2. Right? So in this case, oh, they have given you R into this value as well. Wow. Like I can't make anything much more easier than this. And they have given you directly log 3 and they were saying that it is triple the time. So 3 is log 3 there. Activation energy, put the value 19.15 joule per Kelvin per mole. This is important. They have given you degree Celsius. I have to use Kelvin here. So 17 degree means 1 by 290 Kelvin minus 1 upon 300 Kelvin. Then solve it. Is it clear? So I'm on the verge of completing this portion. And still I have so much time. But what are reducing sugars? In the first session, we have learned reducing sugars are those who can reduce Tollens or Fehling solution. 1 mark. Then we have learned monosaccharide, disaccharide. So your galactose is mono, fructose is mono, sucrose is your disaccharide, lactose is your disaccharide. Disaccharide, we have learned only 3 examples. That is sucrose, lactose, and maltose. Then name a polysaccharide, which is also known as animal starch, means in my body, how I store the starch, that is in the form of glycogen. Why it is called as animal starch? So in human body, when they have to store the energy, they stored in the form of glycogen, that is called as animal starch, human starch, or any animal. So whatever, whenever you are, if those who are non-veg and you are eating the flesh, so in that case, you are actually taking the glycogens from them. And or question, name the isomer. This we have done in the doubt session. The isomer is called as anomer. No enantiomer, no diastereomer, anomer specifically. What is CP? And may I know why this expression? Anything special? Did I said something wrong? No? Okay. So presence of which functional group was detected when glucose is reacted with bromine water? The CHO group. If you have aldehydic group and you take bromine water, it will convert to give you acid. That group was detected here. Then you have a very long paragraph. Okay. Let's see the question. On what basis can you say that copper is a transition element but zinc is not? We learned this question. I don't need to read the paragraph for this one. Copper has unpaired d electron in its electronic configuration of copper plus 2. And in the zinc, we have completely paired electron, no vacant d electron or d orbital or no unpaired electron. So to be a transition element, you required at least 1 electron in any of the oxidation state that it is should be unpaired. Still I'm waiting. But why this expression? Okay, let's go with the next. Why do transition element show variety of oxidation state? Because of decontraction. As the energy gap between n minus 1d orbital and ns orbital is very low, due to this, they are showing a variety of oxidation state. It's a 1 mark question, so you can write this much. Example, I can write it like I have manganese, can show +2, can show +4, can show +5, can show +6, can show +7. Simple. Why do E naught M plus 2 values show irregular trend from vanadium to zinc? Okay, so it decrease, then increase, then decrease, then decrease, increase, sorry, decrease, decrease, increase, decrease. Because of their difference in electronic configuration and their size. As their electronic configuration and size are changing, due to which half-filled, fully filled shell can alter their E naught values. So E naught value actually depend upon the ionization energy, which is altered by electronic configuration and size and size. Is that clear? Good. Next question, what we have here is, okay, let's see. How is the variability of oxidation state of transition metal different from that of non-transition elements? Okay. So oxidation state of transition metal is a variable state because in that case you are having n minus 1d electrons. And their energy gap between ns electrons are very small. So they can show variable oxidation state. Second, as they have vacant d orbital afterwards also because they have force shell, so they can give you a variety of compounds. But in non-transition elements, they cannot show variety of oxidation state. They will stick to their group states. So you can go it with an help of example. So I can say, let's say chromium. So chromium is 3d5 4s1. So I can show 6 oxidation states here. And in non-transition element, let's say if I have oxygen. So oxygen can show either -1 or either -2. Only with fluorine, it goes with +1 or +2. Clear? Good. Of D4 species, chromium +2 is stronger, reducing. This question in the class also, when we were doing, I told you that this question will definitely going to be asked in your paper. So why? Electronic configuration. In this case, if it oxidizes, it will become D3, that is T2G half filled. And manganese +3 is basically your stronger oxidizing agent. It will reduce itself, form Mn +2. It will be D5 half filled d orbital. This is the major reason. Same reason we have learned for the iron also, +2 +1. Okay. Complete the following ionic equation. Yes. So this equation, it is written in NCERT. It will give you MnO2 plus I2. Same, simple. There is nothing more I can do with this question. Then you can balance the equation. Balancing I have taught you. It's a 1 mark question. If you have written this much, you will get half. If you have balanced the equation, you will get full. Next, any 5 we have to do. So we can, let's see all the 5. Splitting energy. I told you in the last DRS session, the delta T is equals to 4/9 of delta naught. See, same question everywhere, which we have learned. IUPAC name. IUPAC name, you can easily do it. There's no issue with that. So it was, so we can go with it, bis. So we have 1,2 dimethylamine. No, so sorry. So, huh, it is portion that is chlorido, dichlorido, and then you have platinum. I don't know what happened. So let's do it again. Okay. So let's see what is the next step here. So in the next step, what we are getting here, write the geometrical, write the geometry and magnetic behavior of the complex nickel CO4. Using the valence bond theory, you can use any theory here. There is no issue. So as CO is a very strong oxidizing agent, sorry, strong field ligand. So in that case, you will be getting nickel in the zero oxidation state. So it will be 3D10. Then we will be having 4s and 4p will be participate. So it will be sp3 hybridized. And the magnetic behavior, it will be paramagnetic. Sorry, diamagnetic. There is no lone pair. Next, what kind of isomerism it will be showing? It will be showing the coordination isomer. Okay, last portion is quite lengthy, so it's taking a lot of time. No issues. And the same questions has been asked, so I'll discuss the ABC portion for the other ones. Let's see the next portion, compound basic crystal field theory, electronic configuration. If the pairing energy is more than the your crystal field splitting energy, so in that case, it will be a high spin complex. Because pairing's energy has to be low, then only it can pair up the electrons. Out of this, which complex is heteroleptic. Heteroleptic means that next we have is draw the structure of optical isomerism of this one. So in the cis condition, I've told you in the last class also, it will be so I have cis condition HCH2 here, CH2 here, and this NH2 here. Because this is a proper drawing question, so I have to draw properly. And instead of that, I write CH2, CH2, that will be better. And then I have chlorine that transform, it is optically inactive. As they were asking only optical isomers, so I can draw this one. If you didn't return the second portion, there is no issue with that. Next, we have is oxidation of aldehyde is easier as compared to ketone. Yes, because the hydrogen is there, acidic hydrogen is there. So you can easily replace with the O. And the case of ketone, you have to remove the alkyl group. Alpha hydrogen atom of aldehyde are acidic in nature. Yes, that is why they're able to show the your aldol condensation. And secondly, it is resonance stabilized. So if I'll get CH2 minus here and C double bond O here, so it will be resonance stabilized here. That is the basic reason. You can see resonance stabilized, mesomeric stabilized, or the minus I effect of C double bond O will also stabilize this one. Okay. Now, see, by seeing this reaction, you need to understand that this is a halophone. Just close your eyes and then you know what is the answer. So we'll get PHCOO along with the formation of CHI3 here, which will be your yellow PPT. along with the formation of ah, nothing, water. Next, okay, this is a property of a cadmium. So whatever the R group is present, it will displace chlorine. So we are going to get pH, C double bond O, and R will be CH3. If I write a balance equation, I'll write 2 and 2 here. Good. Give a simple chemical test to distinguish between ethanoic acid and ethanol. Ethanoic acid, we can go with FeCl3, it will give you buff color. Ethanol, you can go with Tollens reagent and all that. Simple test. Or draw the structure of 2,4 dinitrophenyl hydrazone from benzaldehyde. So we can do it. Benzaldehyde is your CHO, and then you are adding 2,4 dinitrophenyl hydrazone here, so that will be NH, NH2, and at second position NO2, and at the last position NO2, and they were showing the water will move out from here and here, so we are getting pH, CH double bonded with N, NH attached with the benzene ring, NO2, NO2. My handwriting is very bad, it's okay. Next, arrange the following in the increasing order of their reactivity towards the HCN. See, whenever you have an aldehyde, it will be much more reactive. Then the reactivity of ketone, which is smaller groups of R is there, then higher groups. So it is first, then second, and then this will be third position. Then we have the next, how can you convert phenyl magnesium bromide? Phenyl magnesium bromide means they have taken a Grignard reagent. MgBr to benzoic acid. So add CO2. This we have learned as a preparation of the acidic group now. So we'll get benzoic acid here. Next portion. Give a simple chemical test to distinguish between benzaldehyde and ethanol. That is your Fehling solution. And ethanol will show the Fehling solution. Benzaldehyde will not. Next, write the main product in the following reaction. I told you in the last session also NaBH4 is a very weak, your it's a strong one, but it's actually a weak one in comparison to LiLH4. So it will only reduce your ketone or aldehyde group. So the product which is formed here is CH3. This is an NCERT question. CHOH in presence of CH2 and ester remains as it is. Clear? Good. Now the resistance of this much is found to be this much. The cell constant is this much. Calculate the molar conductivity. So there's no issue. They have given you the value of C here, that is be 0.05. They have given you the value of R here, that is 100 ohms. And they have given you the value of L by A here, that will be 0.0354 per centimeter. Right? So what they were asking you, molar conductivity. So molar conductivity is equals to kappa into 1000 divided by C here. So kappa is equals to how much? Kappa is equals to 1 by rho, and R is equals to rho into L by A. So you can easily find out. You just have to remember the formula, direct formula based question. State Faraday first law. So whatever the Faraday first law, okay, that state. The charge. Yes, the Faraday's first law, the charge which is produced there, and the charge which is produced, it's sorry, the charge which is used in the reaction is equals to the number of electrons or the moles of electrons or the charge of the electrons which are transferring. That is a Faraday constant. Or the weight of a component or the compound which is produced. It's directly proportional to the charge travel. How much charge in Faraday is required to reduce 1 mole of this to this. So I am taking MnO4 minus 1. It is taking 5 electrons to give you Mn plus 2. So 5 Faraday charge is required. Straightforward, direct question, direct answers. And the last question of the paper, the molar conductivity of this. So they have given you concentration 0.0025 molarity, and they have given you molar conductivity. No, they have given you only conductivity. Kappa is given to you 5.25 into 10 raised to the power minus 5 Simon per centimeter. They were asking you degree of dissociation if A naught. So you have to find A M here, that will be equals to kappa into 1000 divided by C. And then degree of dissociation alpha direct formula, that is AC by A naught M. So that is 5.25 into 10 raised to the power minus 5 into 1000 divided by, we have C, which is 0.0025 into not M, that will be 390. Clear? So if I'll cancel this one, so I'll cancel here, it will get 10 raised to the power minus 1. Cancel this, cancel this, cancel this, cancel this. What do I left with? 5.25 divided by 25 into 39. Let's cancel this one. So I'll get 100 down. And then I can cancel this value directly. 1. 550 will go on 2. 25 will go on 1. So it will be 21 by 39 into 100. So minus 2 I can take up. 21 will go on 7. It will go on 1, 3, 13. Approximately, if I'll give the answer, it will be 1 by 2. Write anode, cathode, and overall reaction of lead storage battery. Lead storage battery, everybody would know about the PbSO4. Plus, you are getting H2SO4 here, giving you PbO. Yes. That is a simple question. Till here, anyone has any doubt? Good. So in the next question, let's see. In this part, in the class, I have everyone. I don't have much time. So let me just give you the section A1 answers so you can easily compare. So here it is. It's in 6 minus 2. It is in +4, so it will go in +6 oxidation state. So sulfate. En coordination number 6. Then we have which of the following is a non-ionizable. Means outside the square box, there is nothing. So A is the answer. Then you have benzylic, means at benzene, then CH2, and then you have any group. So this is the benzylic position. And then we have phenol is less acidic than ethanol. Orthonitrophenol. Orthonitrophenol will show your hydrogen bond. Methoxy group will show your plus I effect. And even plus R also. So it is destabilizing it. And orthomethylphenyl. So it will giving you plus I and plus H hyperconjugation. So orthonitrophenol is the answer only. There is no other portion. Because the nitro is showing the minus R group also. Hydrogen bonding is there, but minus R is more dominating in comparison to the others, which are showing plus R or plus I. Okay, and this reaction. So I have told you above also, they have given you a same type of a reaction. We have to see where the carbocation is stable. So carbocation is much more stable on 3 degree. So in this case, this will be your iodine will produced here. And you will be getting CH3OH. So what will be the answer? First one. I believe that they have given almost same type of an options also. Aspirin is formed by, we have learned, salicylic acid. No other option. Azeotropic mixture to liquid, higher boiling point means maximum boiling point. They have asked in the minimum, now maximum. So maximum boiling point means negative deviation. Option C. They didn't even change the options. Okay, and aqueous CuCl2. So CuCl2, when it reduces, it will give you chlorine. Plus, it will give you copper because copper is much more in reactivity than hydrogen. So copper will reduce. So here, what do we get here is chlorine gas is liberated at anode, that is wrong. Oxygen at anode, that is wrong. Copper at cathode, that is right. Half-life of first is this much. Calculate the rate constant. Direct formula based question, that is 1386 per second is equals to 0.693 divided by K. Then what do we have is the relative lowering of vapor pressure. Again, the same type of a question which has been asked and direct question. The rate constant they have given you is this much. The rate constant K can be increased by. See, rate constant A, I can't increase by the concentration, I can only increase by the temperature. I can increase rate by changing their concentration, but rate constant will only be affected by the temperature or the your catalyst and everything. Next, assertion and reasoning question. Okay, they were asking this one. Again, this was the same question as we have done, same question as we have done above. Then diazonium salt, same question as we have done above. Last, acid anilide is less basic than aniline. Okay. Acetylation of aniline result in decrease of the electron density on a nitrogen in acid anilide. That is true. This is also true. This is also true and correct explanation. So A is the correct answer. Next, essential amino acid. So essential amino acid is basically which is required by the body from the outside as we can't develop it. Nucleotide, when you have sugar plus it is attached with phosphate group and it is attached with, sorry, OP3 minus 1. And then you will be having a base here. That is called your nucleotide. Nucleoside is when you have only sugar and base. Then again, SN1 question goes with the carbocation formation. So whosoever is the more stable carbocation, so this is more stable carbocation. Benzene ring with CH2, resonance stabilized. The major product, okay, this question has been asked in the class itself. So if I'll have this kind of a question, so major product will be this one. Because at the allylic position, free radicals are much more stable. Then we have first order reaction rate, same question as we have done above. It is a half life. So directly formula based question you can do it. Lanthanide contraction already done. Atomization energy already done. Now 4% urea. Instead of the glucose, now they have given you urea here. So urea will be, they have given you 60. That will be equals to 5.2 by M. So M is equals to 5.2 into 60 divided by 4. So it will go on 230, 115. So 15 into 5.2. Same question as we have done above, direct formula base. Same question as we have done above, direct formula base. Same question as we have discussed. Same question, same 26, same. After that, there are same type of questions which are there. Till this part, anyone has any doubt, any query, any portion which you don't understand? No? Very good. Now let's go with the next portion, the last C part. In the C portion, the only way we need to understand is the sectioning. Otherwise, all the rest are things are almost same. Now, first question, most of the students get confused by seeing the first question. No, you have to see with the oxidation state. So oxidation state. So as we know, vanadium is +5, chromium is +6, and manganese is +7. Higher the oxidation state, more oxidizing power you will be having. So in that case, the answer will be C. You will reduce itself, you will oxidize others. The type of an isomerism which you can show here is, you can show geometrical isomerism also, you can show optical also. So the correct answer is geometrical because optical is not given. Cis compound of this one will show the optical isomerism. Then the type, which one of the following hybrid state is associated with a low spin? Okay, low spin complexes when you have an inner d orbital. Okay, butane nitrile. So butane nitrile means 1, 2, 3, and CN here is heated, can be prepared by heating. Okay, so propyl chloride. Yes, we can do that. Butyl chloride. No, butyl chloride will give you pentyl chloride. Propyl, this will give you propyl alcohol. Alcohol will not react. So our correct answer is A. Which of the following is most acidic? Same question. So in this case, the NO2, because minus charge will be much more stabilized here. This is showing minus R. Or minus M, mesomery. There's no issue with that. Same question as we have done above. Now, a compound X with the molecular formula, this can be oxidized by a strong oxidizing agent. Means it has to be a ketone. C3H8. Okay, there is no 6, 7, 8. So it is actually alcohol. And we need a strong oxidizing agent. So it means it has to be a 2-degree alcohol to get ketone. And the molecular formula is see there. They are specifically giving you that you are forming an acid here. So when you are forming an acid, it has to be the outside position because there is no carbon which is changed here. So if I'll add here any oxidizing agent like KMNO4, so I'll be getting COH here. Next, mixing 10 ml acetone and 50 ml of chloroform, the total volume of the solution will decrease. Acetone and chloroform will form a negative deviation. They are same type. Will be less than 60 degrees. Okay, the unit of cell constant is per centimeter. As you have seen, it was given the question also. A certain reaction R give you product. A plot of log R versus time is given as a straight line of the slope of this one, which is the order. See, they have given you log R, so it is by default your first order. In the log, we use only in the first order reaction. I don't have to solve even this question. The zero order reaction they have given you, T half life will be how much easy they are going to make the paper. And I'm assuming that next you have your physics paper. So understand that they are going to make this paper from the NCERT only. Don't waste your time on doing other portions. Do the NCERT questions, in-text question, and you can see the in-text question which I have given in the last when I have taken the webinar. Most of the questions are directly from there. Direct in-text question, direct your back questions which I have given. So simple, so direct, straightforward questions. Let's just complete this one and so we can move ahead. The relative lowering of vapor pressure, again, we have done the same question. Assertion and reasoning. Aniline is a weak base than cyclohexamine. That is true. Aniline is resonance stabilized. That is also true. A is the answer. That is the reason now why, because the lone pair is in the resonance. Vitamin C cannot be stored in our body. Vitamin C is a water soluble and readily excreted out in the urine. That is also true. A answer. Then we have aminolysis of alkyl halide involved. That is why you need to eat vitamin C. Either you can eat lemon, oranges, or vitamin C supplements. Don't go supplements, take normal, take amla. Aminolysis of alkyl halides involve the reaction between alkyl halide and ethanoic solution of amino. Yeah, we can have ethanoic solution, there's no issue. Aminolysis of alkyl halide mainly produces secondary amine. This is fault. I can have primary, secondary, tertiary, quaternary. All the amines we can produce. So it is C option. Aniline do not give Friedel-Crafts reaction. Friedel-Crafts reaction is a nucleophilic substitution reaction. Yeah, this is false. This is true. C option. Which one of the following pair of a substance SN1? So you can go again. I have told you, so you have to just see the carbocation reaction. NaOH, this is directly the Dow reaction, the Dow process. So what do we get here? I'll get OH above. NO2 remain as it is. Lanthanide contraction already asked. Enthalpy atomization already asked. Peptide linkage when you have amino acids are linked together. This is your peptide linkage. Essential amino acid, which we have to take from the outside. Same question, half reaction, T half life, same question. Phenol from chlorobenzene, same. Rest everything was similar. Here you have any doubt, any query. Now you can take your doubts. Anyone? With this, we have done with all the portions. Okay, I forgot the last paper. So ambident ligand, HCN, we have only 3 ambident ligand, SCN, NO2, and your CN. Adding AgNO3 in the 1 mole of this much, 1 mole of AgCl is produced. So 1 Cl is outside only. So what do I have here is CO, then you have NH3 whole 4, Cl2 will be inside and one Cl will be outside. So secondary valency of CO will be. This is actually, I don't need to do this question. Secondary valency means this coordination number. So answer is 6. Whosoever has mark 3, don't. Which of the following element, 3D transition element, has lowest activation energy? Zinc. Scandium, no. Zinc. Zinc is brittle. It has the lowest atomization energy. SOCl2 replaces OH. So I'll get PH, CH2, and I'll get Cl here. Phenol, it will not able to replace. So OH will remain here. Yeah, this is the correct answer. Good. And which of the following Grignard reagent, methanol? Okay, I have to react this with a methanol to get this one. So I require this. It will react with methanol. There's no ethanol here, child. There's a methanol here, so it is CH double bond O2 here. Then ether group, again, as the both sides are same, so you can produce anything. Here, which will not react with benzene sulfonyl chloride, that is your Hinz-Dicker reaction, so it is 3 degree. Next we have is scurvy. Scurvy is caused by vitamin C deficiency. So eat amla every day. 1% X isotonic, same question. Half-life, same type of a question. Hearing aid machine, that is your mercury cell, not dry cell. Mercury cell we use in the hearing aid machines. It was specifically written in the NCRT book. Mercury cells are small button cells which are used in the smaller machines like your hearing aid machines or your watches, hand wristwatch. Then aniline react with bromine water to give you 2,4,6 tri-bromo, and that is why we need to protect aniline. And assertion and reasoning, delta H and delta V of mixing is 0 for ideal solution, true. The solution which obeys Raoult's law over the entire range of concentration is called the ideal solution, that is also true. And they are correct explanation of each other. Rate of reaction decreases with increase in temperature, that is false. Rate of reaction increases with the increase in temperature. The number of effective collision increases with the increase in the temperature. This is true, so answer will be D. Phenol on reaction with the aqueous NaOH gives sodium phenoxide. True. The reaction supports the acidic nature of phenol. That is also true and correct explanation. Boiling point of butane 1 all is higher than that of butane 1 aniline. Amine. Okay. True. More hydrogen bonding. Alcohol shows more hydrogen bonding in comparison to the anilines. And being more polar, butanol forms stronger intermolecular hydrogen bonding. That is also true, correct explanation. See, everything was same. With HI and other portions, so HI will reduce them. And in the red phosphorus, so you have to add red phosphorus here. And then with the other one, it will give you acetyl formation. Correctly written here also. And other things are very easy. Till this part, anyone has any doubt or anybody? Any portion which you didn't understand? No? Molar depression constant, they were asking you KF. Enthalpy, so it will be molar mass into sorry, T freezing point naught upon delta H naught F or the fusion. Understood everything? Exam was well done. And now I wanted to know, I hope the exams went really well for everyone. Is there anyone who has this feeling that your exam did well, gone good, or is there any portion which you don't understand? Any part in the question? Was a direct, straightforward questions which they have asked. If you still have any query, you can ask. Any part, anything which you don't understand. See, for your next class, for physics, Those who have done this paper correctly, very good. Those who haven't done it, again, I'm telling you, don't pressurize yourself. It's okay, it happens sometimes. The paper has been done now, you can't change anything. Move on. In the physics, not understand that they are giving you from the NCRT portion, do the NCRT questions, solve all the NCRT questions. You have a time, don't make your time go waste. Learn from the tomorrow morning, start doing with your NCRT part and solve every single question there and whatever your teacher respective teachers have told you. If you need any help, you can message on the group or on the chats. Let the teachers know about it and they can reply you. I hope everyone doubts are clear till now. Yes, no, yep. Okay, so on this note we are ending here. If you still have any query, I'm waiting. If you still wanted to say something, that will also. You're welcome. No, everything is going fit and fine. Good. So all the best. Do study hard for your final examination. And after that, the portions which you have learned, just revise those portions for your IIT means because it is just coming after 1 month. Bye. Take care, guys. Enjoy and study hard.